Okay, so we have our third chapter review packet. So at first, let me go back up here, take a look at this. For this rotation, it's a little tricky. We have to find the center of rotation, which there's a method to do that. But for now, I have the approximate center. I estimated where it is. Basically, you have to find the center and the angle for any rotation. For a line reflection, we could have the line of reflection is the perpendicular bisector. So what I said here for the line reflection, we're still working on that. Okay, so what you're going to look for is the direction that the point has to travel, which is perpendicular to the line of reflection, and the distance. So these slashes here, that marks that they have to be the same distance. So if you call this A prime has to move perpendicular to the line of reflection and the same distance from the line of reflection. So we need a direction, which is perpendicular, and a distance. All right, for translation, we just need a distance and a direction to travel. Now, last year we talked about vectors, directed segments that kind of got left off this year. So we're just going to say distance that it's traveling, okay, and a direction. Watch out for that distance part. If it's straight across, that's easy, but if it's at an angle, we might have to do the Pythagorean theorem to get the distance. So just keep that in mind as you go through this. Okay, so I'm going to go through all of the steps here. So first, I'm graphing y equals x. And what I tend to do with these lines that are slanted, I try to create the path that is perpendicular first. Now, I'll go too far. You'll see that I traveled too far. This has a slope of 1. So what I'm going with a slope for A prime is it should travel at a slope of -1 from A. So I'm going to go up 1, left 1. Now I'm going to go too far, and then I'm going to come back and I'm going to count. Okay, so after I establish a direction, then I come back and count a distance. So I'll erase and then reflect over y equals x. See, I'm graphing that right now. And same thing. You'll see me create a path that's perpendicular first. Then I'll go back and count a direction. I think it's important for students to make sure that they, plot that path that your image is going to travel. That's really an essential step. And if you noticed, some of you might have gone A to A prime, which was over here. And then from A prime, reflected over the y equals -x line. I didn't. I went back to the original each time. If you did that, so let's say you did continue, you'd be in a different location. And that's all right. It really wasn't clear on the directions. Okay, so when I rotate, what I try to do is talk about the quadrants. So it's currently in quadrant 4, and I want to make sure that a 90-degree rotation is going to take me to the next quadrant in a counterclockwise direction. So that's just the way the quadrants go. So I make sure that A prime travels here. Please don't be, or triple prime actually. Please make sure that you don't just, it looks like you could get away with just reflecting over the line of the x-axis. Make sure that we're actually creating a perpendicular 90 degrees from A to the origin to A prime. So I'll show you how I do that. So I wrote down it's traveling from quadrant 4 to quadrant 1. Now what you're going to notice is to get from A to the origin, my change in y is 4, my change in x is 2. Now you could spin the paper or just switch those. Change in x is 4, change in y is 2. Okay, 90 degrees about the 0.31. Now this is tricky. So what I've taught students is there's the 0.31 pretend that's your new origin. Just, imagine or think in your brain that that's the new origin. Now, A, relative to that new origin, has a change in y of 5 and a change in x of 1. So to move 90 degrees from it's going to act like the third quadrant in this green axis. It's going to travel over to here. So I'm going to switch it. I'm going to go right 5 and down 1 to move it one quadrant. Now I'm pretending, right, that the green is my new axis. I'm pretending this 0.31 is my new origin. Okay. It's not really, but that's how I'm working this. Okay, so you see I'm switching the change in y and change in x and getting into the correct quadrant. After you land on the correct spot, now you have to go get that coordinate relative to the true origin, 0, 0. And I believe it's going to be over at, 8, 0? Yeah, 8, 0. All right, a rotation of 180. For rotation of 180, I'm basically just going to make, I'm going to make the center of rotation basically the midpoint of A to the 5th image of A. So I'm going to count up 5, right 1. I'm going to repeat it up 5, right 1. And that will make, so if you have a straight path, it'll make a straight angle, which is 180 degrees. All right, reflection in the line x equals 0. Make sure that this is a little bit tricky, but it's the y-axis. Let's not get confused. X equals 0 is a vertical line. Any line that has x equals a number as the equation is a vertical line. So x equals 0 is going to be this vertical line, the y-axis. Okay, so again, we don't tend to draw the path when it's straight up and down, straight across, but I did just to exaggerate that idea of line reflection. We're just going to, since the path is already plotted, we're just going to count 2 to the mirror, 2 more to the image. All right, that should be it for the first page of the review packet.